This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at partial derivatives, and I think you'll like these. They're pretty straightforward. Let's look at our first one and demonstrate how to find them. Later on in a different lesson, we talk about what are they used for. But let me just briefly talk about it. When we found derivative before, in when we just had x's and y's, we found a derivative at this point. It gave us the slope at that point, the slope of the tangent line. And when you're talking about 3D, though, you got a three-dimensional object here. Sphere is about the best one I can draw, like that. And if we look at a particular point, it's just not two-dimensional like this, it's three-dimensional. So we can take a look at the rate of change of the x component and of the y component. And that's what we'll be taking a look at here. Now, our first one here says find both first partial derivatives. So first thing we're going to do is we're going to find the derivative with respect to x. Now this is the way the notation looks. This f and then this little x right here. That means we're going to find the partial derivative with respect to x. Basically, you treat the y as a constant, and then take derivative with respect to x. So 7x becomes 7. Now, since we treat this as a constant, that drops away, and then the 1 drops away. So our answer there would be 7. Now we can also take this with respect to y. And again, we treat the x component here, the term, as a constant, so that drops away. And derivative of negative 3y gives us negative 3. And those are our answers. Okay, so here we got f of xy is equal to 8x squared y to the third minus 7y plus 4x to the fifth. And we're going to take derivative with respect to x, the partial with respect to x, I should say. And again, we were thinking of this, normally this would be like the product rule, be kind of, well, not difficult, but it'd be a little bit more than just writing the answer down. But since we're treating this like a constant, the 8 and the y to the third just stay there, and I take derivative of the x squared. So 2 goes out in front, and then we lower our power by 1, and the y to the third stays there. So the 8 stayed there, the y to the third stayed there, I just took derivative of the x squared. Minus, oops, okay, forget that. There's no x here, that drops away. And then this becomes 20x to the fourth. Take your power, put it out in front, lower it by 1. So we get 16x, y to the third, plus 20x to the fourth. And that's our answer. Now if I take the partial with respect to y, again the 8x squared, just like a constant, just stays out in front. So we'll take this power, put it out in front. So we got 8x squared times 3y squared minus 7. Derivative of negative 7y is negative 7, and this drops away. So that gives us 24x squared y squared minus 7. Number 3. We got z is equal to e to the 2x minus 5y. Now this is I like this notation up here real well because it's so easy to write it, and as you take second partial derivatives, third partial derivatives, it's so much easier to keep track of everything. On this one, for the partial derivative notation here, it's going to look like this. We're going to take the partial derivative of z with respect to x. Now the derivative of e to any power is just e to any power, so that doesn't change. So this stays e to the 2x minus 5y. But then you have to multiply it times partial, oops, sorry, the partial with respect to x of the exponent. Okay, so let me say that again. Derivative of e to the power is e to the power, but then you have to multiply it times the partial with respect to x of the exponent. Well, the derivative of 2x minus 5y in terms of x, the negative 5y drops away, and derivative of 2x is 2. So we get 2e to the 2x minus 5y. Now taking the partial, that's not a 2. That's refers to partial. I don't draw them real well. You may think that's a sloppy 2. It's not. Can I show you what the symbol should look like? Okay, what the symbol should look like. That's probably big enough. Should be that symbol right there. But what you're seeing is close as I can get. Okay, so we're going to take partial of this with respect to y. So, the derivative of e to any power is e to any power. That never changes. But then, we want to multiply it times the partial with respect to y of 2x minus 5y. Well, the 2x we treat as a constant, so that drops away. Derivative of negative 5y is negative 5, so this is negative 5 e to the 2x minus 5y. And number 4. We got z is equal to natural log of 5x squared minus 3y squared. And wants us to find both first partial derivatives again. So I'll take the partial of z with respect to x. Well, the derivative of natural log of something is always 1 over whatever's inside the parentheses. So that doesn't change. This is 1 over 5x squared minus 3y squared. But then, by remember the chain rule, we had to multiply it times the partial with respect to, in this case, x of 5x squared minus 3y squared. So again, when you got natural log, the derivative of it is always 1 over whatever's inside the parentheses times the partial with respect to x of what's inside the parentheses. Well, the negative 3y squared, again, we treat as a constant, so that drops away. So the derivative of this gives us 10x over our 5x squared minus 3y squared. Now the partial of z with respect to y. Well, again, derivative of natural log of something is always 1 over whatever's inside the parentheses times the partial derivative with respect to y of what's inside the parentheses. Well, 5x squared treats a constant, so it drops away. The derivative of negative 3y squared is negative 6y. So we're going to have negative 6y over 5x squared minus 3y squared. And do I have room for the next one? Might not. Let me save that. Calc 3 partial derivatives page 01.pdf. Okay, problem number 5. Let me grab a drink. It says find both first partial derivatives again. So we got z is equal to cube root of 8xy minus y squared. Okay. Well, I need to put this in the right form to begin with. So I'm going to rewrite this as 8xy minus y squared to the 1/3 power. we always want to put it in rational exponent form, fractional powers. Then, taking the partial of z with respect to x, we have parentheses to a power. Well, this is a general power rule. Anytime you have parentheses to a power, take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. And then you multiply it times the derivative with respect to x. So partial derivative with respect to x of what's inside the parentheses. Okay, let me say that again. You got parentheses to a power, take your power, put it out in front. What's inside the parentheses remains as is. Lower it by 1, and then you take it times the partial derivative of what's inside the parentheses with respect to x. Now this gives us 1/3 8xy minus y squared to the negative 2/3 times the negative y squared, consider a constant, so that drops away. Derivative and the 8 and the y stay there, and derivative of x, that drops away. So this becomes 8y. Again, I took the derivative with respect to x, thinking of the y as a constant. Now, if I didn't have the y there, the derivative of 8x is 8, isn't it? So again, the y just treated as a constant. Well, I'll put this into a single fraction. The 8y goes on top. The 3 is already down here. This parentheses to negative 2/3 power, I'll take it down to the denominator. It'll become a positive 2/3 power. So we got 8xy minus y squared to the positive 2/3. And that's our answer. Now let's take the partial with respect to y. Well, again, take your power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. And then we'll multiply it times the partial derivative with respect to y of what's inside the parentheses. Okay, so we'll have 1/3 8xy minus y squared to the negative 2/3 times, again, we'll take the derivative with respect to y, so 8xy just becomes 8x, minus derivative of y squared is 2y, like that. Now I'll put these into a single fraction, so I'll put the 8x minus 2y up on top, put the 3 down here. This negative power here I'm going to take down below. This becomes 8xy minus y squared to the positive 2/3. And that's our answer. Okay, let's take a look at our 6th example. We got f of xy is equal e to the x squared minus y cosine of x squared y. Okay. We'll take the first the partial derivative with respect to x, and first thing I notice is that this has an x in it, and this has an x in it, and so we got e to an x power and cosine of x, which means I'm going to need to use a product rule, and this right here will be my p, and this will be my q. P prime. Again, I'm taking the derivative with respect to x, so the derivative of e to a power is e to the power, that doesn't change, times, oops, there should be a y, I think, assuming my eyes didn't get off. Yeah. Now we're taking with respect to x here, so the derivative of e to the power is e to the power times the derivative of the power. And with respect to x, we'd have 2x. So p prime is going to be 2x e to the x squared minus y. Now for q prime, derivative of cosine is negative sine. So this will be negative sine x squared y times, and this is chain rule, since we got more than a single variable in here, we have to multiply it times the derivative of that with respect to x. Well, with this respect to x would be 2xy, which gives us negative 2xy sine x squared y. Let me double check those. The phone was ringing and it's throwing off my concentration. Okay, taking derivative, we're doing this with respect to x. So the derivative of that, okay, 2x. And derivative of this respect to x, negative sine times 2xy. Okay. Now our formula again for the product rules, p prime q plus p q prime. So the partial with respect to x is going to equal to p prime, which is 2x e to the x squared minus y, times q, which was cosine x squared y, plus p, which was e to the x squared minus y, times q prime, which is negative 2xy sine x squared y. Now I'm guessing they probably factor out what they have in common. They both have a 2x e to the x squared minus y. So 2x e to the x squared minus y. That's gone, that's gone, that's gone. So that gives me cosine of x squared y. That's gone. This 2 and this x is gone. So we got minus y sine of x squared y. Assuming I didn't make any basic algebra mistake there. I hate when a dog starts barking outside or the phone rings. It just throws me off. Oh, limit definition. Okay, let me save that. Now our limit definition. Got 2. And I'm going to put this, I guess I'll use this notation. Partial of z with respect to x is going to equal to the limit as delta x goes to 0 of f of x plus delta x comma y minus f of xy over delta x. And we also have the partial of z with respect to y. Now this is, we've been using a shortcut on these, but this is how they derive some of these original formulas. And prove that you can do them with respect to certain variable. Let's see, this would be x, and then this would be y plus delta y minus f of xy, and over delta y. And we're basically just going to look at how to use these definitions with some problems. This is like phase 1. Phase 2, I plan to go back and put proofs out there in my website. Let's see, where's it at? So let's take a look at this one. So we got f of xy equals x squared minus 3y. And it says to use the limit definition of partial derivatives to find partial respect to x and partial respect to y. So let's do that. So the in order to, we'll first find the partial with respect to x. And that's his first formula here, with respect to x. So we need to find, so the first thing we do is we find f of x plus delta x y. And then we just plug it in our formula. Okay, so we saw this in an earlier lesson. This will plug in for x, this will plug in for y. So the y doesn't change. So I'm going to go through where my x is, I'll put in parentheses. Where my y is, I put in parentheses. And new x is x plus delta x, and then new y is y. So this gives us x plus delta x times x plus delta x, that's what that means, squared means, minus 3y, equals x times x is x squared, x times delta x is x delta x times x is x delta x times delta x is delta x squared, minus 3y. Now the x delta x's are the same here, so you add the numbers that are in front, and we get x squared plus 2x delta x plus delta x squared minus 3y. I'm trying not to skip any steps here. I did that in class, and if I remember right, I screwed this up. So I'm being a lot more careful here. You'll find you start skipping steps, and that's where usually you go wrong. So we'll plug in our formula. There we go. Okay, so we're going to have a limit as delta x goes to 0, and this we just found in our first step, so we'll plug that in. So we got x squared plus 2x delta x plus delta x squared minus 3y minus f of xy, which was the x squared minus 3y. So x squared minus 3y all over delta x. Well, we'll have x squared plus 2x delta x plus delta x squared minus 3y. If you have a negative in front of your parentheses, it's going to flip the sign of everything inside. So this becomes a negative x squared plus 3y over delta x. Now the main problem is the delta x down below, so that's what we're trying to get rid of, our goal. This x squared here cancels with this negative x squared. This negative 3y cancels with this positive 3y. So up on top, we have 2x delta x plus delta x squared over delta x. And you notice everything up on top has a delta x, so I'll factor that out. So we've got limit as delta x goes to 0, and we got delta x. When we factor that out, that leaves us 2x plus delta x over delta x. Now up on top, we got delta x times something, so this delta x cancels that delta x. You can only do that if you got multiplication up on top. So we got limit as delta x goes to 0 of 2x plus delta x. And now we can plug our 0 in for delta x. So we got 2x plus 0, which gives us 2x. Now, look at our original problem. If we took the derivative of that with respect to x, if we treat negative 3y like a constant, it drops away, and derivative of x squared is 2x. So that checks. So you can kind of do checks on these to see, using a shortcut we've already talked about. Let me save this page. I don't think I got room for part 2 down below. Or do I? Actually, part 2 is simpler. So let's look at that. Okay, so we want to find partial respect to y. Well, from our formula up here, we need f of x, y plus delta y. So let's find that first. So f of x, then y plus delta y. We're going to plug this in for our x, so x remains x, and we'll plug this in for our y into our original function. Original function was x squared minus 3y. So I go through, and everywhere I have variable, I put in parentheses. X is x, and y is y plus delta y, which gives us x squared, and I'll multiply the negative 3 through, so we got minus 3y minus 3 delta y And now we're ready to plug in our formula. So, oops. Okay, so partial with respect to y is equal to the limit as delta y goes to 0 of f of x y plus delta y minus f of x y over delta y. So we plug in what I found. So we got limit as delta y goes to 0. And up here in our first step we found this was x squared minus 3y minus 3 delta y minus f of xy. F of xy was x squared minus 3y. And you always want to make sure you put that inside of parentheses, because the minus has to flip sign of everything that follows it over delta y. So we got limit as delta y goes to 0, x squared minus 3y minus 3 delta y, and the negative out in front of the parentheses flips the sign of everything inside. So we got negative x squared plus 3y over delta y. Okay, so combine together like terms. X squared minus x squared drops away. Negative 3y plus 3y drops away. And we're left with negative 3y, or negative 3 delta y over delta y. Well, the delta y's will cancel, and we got limit as delta y goes to 0 of negative 3. And there's no delta y to plug anything into, so our answer is just negative 3. And if I take a look at my original function, take the partial derivative with respect to y, the x squared drops away, and the derivative would be negative 3. So that checks. Let's save that page. Yeah, let's look at next problem after I get a drink. Got f of xy is equal to e to the x y to the third 0, 2. Okay, instructions are to evaluate the partial derivative with respect to x and respect to y at the given point. So let's go ahead and find our derivatives first. So I take the partial with respect to x. Well, y to the third we treat as a constant, so it just remains, but derivative of e to the x is e to the x. It's not a very exciting one. Then the partial with respect to trying to figure out if I can fit two problems on this page. Oh well. Take the partial with respect to y. Again, e to the x part is like a constant, so it just stays there. So the derivative of y to the third is 3y squared, so this becomes 3 e to the x y squared. Now when it says evaluate at the given point, this is our x and this is our y. So we're now going to plug those in for x and y. So x is 0, so we got e to the 0 times 2 to the third. Y is 2. Now anything in the 0 power is 1, so that drops away, and 2 to the third gives us 8. Now in this one, again, we'll take the partial with respect to y and plug in 0 and 2 for x and y. So we got 0 for the x, and y was 2. E to the 0 is 1, so it drops away. 2 squared is 4 times 3 gives me 12. Again, that gives me my rate of change with respect to x and respect to y at that particular point. Let's take a look at this one. Okay, equals 3x minus y over 2x plus 5y. 1, 2. And it's same instructions. Evaluate our partials with respect to x and y at the given point. So I need to find derivative first. Okay. Got f of xy is equal to 3x minus y over 2x plus 5y. First thing is we'll take the partial with respect to x. So this will be p and this will be q. This will be the quotient rule. P prime, the derivative of that with respect to x would be 3. And q prime, the derivative of that with respect to x would be 2. Again, the y's drop away because we treat them as constants. So then this will be p prime q minus p q prime over q squared. So our partial with respect to x, p prime is 3 times q, which was 2x plus 5y, minus p, which is 3x minus y, times q prime, which is 2, all over q squared, which is 2x plus 5y squared. Okay. Doesn't look like there's any GCF up on top, so we'll go ahead and multiply everything together, combine together like terms, so forth. 3 times 2x gives us 6x. 3 times 5y gives us 15y. This negative goes to the 2, so we got negative 2 times 3x gives us negative 6x. And negative 2 times a negative y gives us a positive 2y. And then the bottom part remains as is. Okay, 6x minus 6x drops away. 15y plus 2y is 17y over 2x plus 5y squared. And now we're ready to plug in our point. So plug in the 1 for the x and 2 for the y. So I'll have 17 times 2 over 2 times 1 plus 5 times 2 squared, which gives us 34 over 5 times 2 is 10, plus 2 is 12, so 12 squared, which is 34 over 144. They're both least divisible by 2, so that's 17. This one's 72. Assuming no basic math error, that would be our answer. Wish I could remember what I came up with in class. That looks right. Okay, let's find the partial with respect to y. So we're going to have f of xy is equal to 3x minus y over 2x plus 5y. Quotient rule. So again, top is p, bottom is q. P prime, the derivative of 3x minus y with respect to y is going to be a negative 1. And for q prime, the derivative of 2x plus 5y with respect to y is going to give us 5. So we got p prime q minus p q prime over q squared. So the partial with respect to y, p prime was negative 1 times q, which was 2x plus 5y, minus p, which was 3x minus y, times q prime, which was 5, over 2x plus 5y squared. Well, they don't have any GCF, so I'll go ahead and multiply everything through. Negative 1 times 2x gives us negative 2x. Negative 1 times 5y is negative 5y. This 5 goes in front, so we got negative 5 times 3x gives us negative 15x. And negative 5 times negative y gives us a positive 5y. Over 2x plus 5y squared. Again, simplify a little bit before we plug in our numbers. Negative 2x minus 15x is negative 17x. Negative 5y plus 5y drops away. Over 2x plus 5y squared. And now we'll plug in our point. This is x, this is y. So we're going to have negative 17 times 1 over. It'll be the same as the last one, but I'll go ahead and write it down again. 2 times 1 plus 5 times 2 squared. So we got negative 17 over 12 squared, negative 17 over 144. I won't do all the steps. Assuming no basic math error. Go up and take a quick look at it. Yeah, it looks right. So let me save that. And let's look at the next problem. So we got g of xy is equal to 7 minus x to the third minus 2y squared at the point 106. Remember, this is 3 dimensions. The g of xy is like z. And it says find the slopes of the surface in the x and y directions at the given point. So let's first find the partial with respect to x. 7 drops away. The derivative of negative x to the third is negative 3x squared. And we treat negative 2y squared like constant, so it drops away. So then we're going to plug in 1 and 0. Now we don't worry about the 6, because that's a z. This is the x and this is the y. So I'll plug 1 in for the x. So I got negative 3 times 1 squared, which gives us negative 3. There is no y there, so I couldn't plug it in. Now the partial with respect to y. 7 drops away, the negative x to the third drops away, the derivative of negative 2y squared gives us negative 4y. And again, we'll plug in that point, 1, 0. So that gives us negative 4 times 0, which gives us 0. And those are our answers. Now this one, we get into four dimensions. So let's see, we got w is equal to the cube root of, what did I do? Just hit the down arrow. I think my fat little fingers were on that, but I guess they were. That's better. Cube root of 3x squared minus y squared plus 5z to the fourth. Okay, it says find the first partial derivative with respect to x, y, and z. Okay. Well, let's put this into radical form first. Or not, I mean rational exponent form. So we're going to have 3x squared minus y squared plus 5z to the fourth, all to the 1/3 power. And now let's find our derivatives. So we're going to take the partial of w with respect to x. Well, we got parentheses to a power. It's always the same. You take your power, put it out in front. What's inside the parentheses remains as is. You lower your power by 1, so we got 1/3 minus 1, times, and then you take the derivative of what's inside the parentheses with respect to x, since this is the partial with respect to x. Well, the negative y squared plus 5z to the fourth drops away because we treat those as numbers, constants. The derivative of 3x squared gives us 6x. And so now the 1/3 times 6 gives us 2. So we're going to have 2x times 3x squared minus y squared plus 5z to the fourth to the negative 2/3 power. And I'll take the negative power, put it down in the denominator. So we'll have 3x squared minus y squared plus 5z to the fourth to the positive 2/3 power. And that's our partial derivative with respect to x. Okay, let's look at the partial with respect to y. Well, again, same idea. Take a power, put it out in front. What's inside the parentheses remains as is. Lower your power by 1. Now we're going to multiply times the derivative of what's inside the parentheses with respect to y. So 3x squared is a constant, so that drops away. The 5z to the fourth is a constant, so that drops away. The derivative of negative y squared is negative 2y. And put that all into a single fraction. Well, actually, go ahead and put the step there. So I got 3x squared minus y squared plus 5z to the fourth to the negative 2/3 power. Now put it into a single fraction. So we'll have a negative 2y on top. 3 times 3x squared minus y squared plus 5z to the fourth to a positive 2/3 power. Okay, let's take the partial with respect to z. So partial of w with respect to z. Again, power goes out in front. What's inside the parentheses remains as is. Lower your power by 1. And then we're going to multiply it times the derivative of what's in the partial derivative of what's inside the parentheses with respect to z. So 3x squared minus y squared drops away, and derivative of 5z to the fourth is 20z to the third. So that equals 1/3 times 3x squared minus y squared plus 5z to the fourth to the negative 2/3 power times 20z to the third. And put it into a single fraction again. And we're going to have 20z to the third up on top, 3 down below, and 3x squared minus y squared plus 5z to the fourth to the positive 2/3 power. And those are our answers. Let me save that page. There we go. Oops. And let's look at our next problem. Let me grab a drink first. We want to evaluate the three partial derivatives with respect to x, respect to y, respect to z at the given point. Okay, so we got f of xyz is equal to 2x squared z minus 4x y squared z to the third minus 5y to the third z squared at the point 1, 0, 3. 2x squared z minus 4x y squared z to the third. Yep, that all looks right. And evaluate the three partials at the given points, so we need to find them. So our first one with respect to x. Again, everything we treat like a constant except for the x. So the 2 and the z just remain. The derivative of x squared is 2x, so this becomes 4xz. Actually, let me show the steps. Okay, the 2 remains, the z remains, and then derivative of x squared is 2x. Minus, the 4 remains, the y squared remains, the z to the third remains. We treat them all as constants. And then derivative of x, well, that's 1, so that drops away. Minus, scratch that. There is no x in this last one, is there? So that's a constant, so that drops away completely. So this gives us 4xz minus 4y squared z to the third. Let me double check that. Okay, so now we'll plug in our point. So we'll plug in 1, 0, and 3 for x, y, and z. So we've got 4 times x is 1, times z, which is 3, minus 4 times y squared, which is 0 squared, times z, which is 3 to the third. Well, 0 squared is 0, times anything is 0, so that all drops away. And 4 times 1 times 3 gives us 12. And that's our answer to the first part. Okay, so let's find a partial now with respect to y. Oops. Well, the 2x squared z, there's no y here, so all that's constant, so that drops away. And on here I'll have negative 4x z to the third. And then the derivative of y squared is 2y. Minus, the 5 remains, the z squared remains. And take derivative, we treat those as constants. So take derivative of y to the third, and that gives us 3y squared. So that gives us negative 8x y z to the third minus 15 y squared z squared. Now let me double check that. Negative 8x y z to the third minus 15 y squared z. Okay, so let's plug in our point now. Plug in 1, 0, 3 for x, y, and z. We've got negative 8 times x, which is 1, times y, which is 0, times z to the third, so we've got 3 to the third, minus 15 times y squared, which is 0 squared, times z squared, which is 3 squared. And this is 0, so that just gives us 0. And let's take the partial with respect to z. Sitting here drinking too much water, now I gotta go bathroom again. You'd think I would learn. My throat gets really dry when I'm doing these lectures, so I can't constantly sit there and drink. So anyway, the 2 and the x squared remain. Taking derivative of the partial with respect to z, so this drops away. I'm just left with what's in front. This one, take my 3, put it out in front, so I'm going to have negative 12x y squared z squared. I think you're seeing the pattern on these. So minus, and derivative of z squared, take my power, put it out in front, so 5 times 2 is 10, y to the third z. Of course, since I'm skipping steps, that probably means that I'll screw it up, so let me double check myself. Minus 12x y squared z squared minus 10 y to the third z. Okay, so now we'll plug in everything. So x is 1, so we've got 2 times 1 squared minus 12 times 1 times 0 squared times 3 squared minus 10 times y, which is 0 to the third, times z, which is 3. Those zeros drop away, and we got 1 squared, which is 1, times 2, which gives us 2. And that's right. Answers. Okay. Evaluate the 3 partials at the given point again. And grab a drink. I think I have room here. Maybe. Yeah. So we got f of x, y, z equal to x squared tangent of z minus y and at the point 2, 0, pi over 4. Okay, well, let's find our partials. Partial with respect to x. Tangent z minus y, that's just like a constant, so it just remains. And derivative of x squared is 2x. And then the tangent z minus y remains. Now if we plug in our point, plug in 2, 0, pi over 4. I'm going to have 2 times x, which is 2. Tangent z, which was pi over 4, minus y, which is 0. Which gives us 4 tangent pi over 4. Now if you remember at pi over 4 on our unit circle, the point is square root of 2 over 2 and square root of 2 over 2. Tangent is y over x. So if I put square root of 2 over square root of 2 over 2, it gives me 1. So this is 4 times 1, which gives us 4. Okay, let's find the partial with respect to y. The x squared is a constant, so it just stays out in front. The derivative of tangent is secant squared. So we're going to have x squared, secant squared, and what's inside the parentheses remains as is. And then you have to multiply times the derivative of what's inside the parentheses. This is chain rule. Well, we're taking it with respect to y, so the z drops away, that's a constant, and the derivative of negative y is negative 1. Which gives us negative x squared, secant squared, z minus y. Well, now we'll plug in our point. So plug in 2, 0, pi over 4 for x, y, and z. So minus 2 or x is 2, so we've got minus 2 squared, secant squared of pi over 4 minus 0. So that gives us negative 4 secant squared of pi over 4. Now secant is 1 over x. So if I look over here at my point, pi over 4, x is square root of 2 over 2. So we're going to have negative 4 times 1 over square root of 2 over 2 squared, the secant squared. We'll flip this fraction, multiply times the top, so this becomes 2 over square root of 2 squared. 2 squared is 4. Square root of 2 squared is 2. 4 divided by 2 is 2, so that gives us negative 8. Okay, so now let's find the partial with respect to z. Well, again, the x squared is a constant, so it just stays out in front. The derivative of a tangent is secant squared. And what's inside parentheses remains as is. But it's a chain rule. We have to then multiply times the derivative of what's inside the parentheses with respect to z, because we're taking the partial with respect to z. The negative y drops away. The derivative of z is 1. So we got x squared, secant squared, z minus y. And now we'll plug in our point. 2, 0, pi over 4. So we got x squared, so we got 2 squared, secant squared of pi over 4 minus 0. Now that pi over 4 minus 0, that's the same as the one we just did. And if I looked at the secant squared, 1 over square root of 2 over 2 squared, 2 over square root of 2 squared, which gave us 4 over 2, which gave us 2. So this becomes 2 squared is 4 times 2, which gives us 8. And you could go through all those same steps if you want, but you'd see it gives you that. So let me save that. There we go. Time for my tablet to blow up, so I'll bring up a fresh copy. And let's look at the next problem. Let me grab a drink too. Find the 4 second partial derivatives. Observe that the second mixed partials are equal. What in the world is this referring to? I'm going to use a different notation than z. I like the other notation to show this. So f of x, y, z. Wait a minute, is that a z? Oh, okay. Never mind. I'm thinking of the w. So f of xy is equal to x to the fourth. Those are interchangeable, by the way. You kind of choose which one you like best. Y plus y to the third. Okay. Now let's first find our first partials. So we'll find a partial with respect to x of xy. And again, take derivative, treating the y's and the numbers like constants. So the x to the fourth would become 4x to the third. The derivative of x squared is 2x, and I already got a 7 out there, so that gives us negative 14xy. And this is a constant, so it drops away completely. And then our partial with respect to y. The x to the fourth, there's no y there, so that drops away. Minus 7x squared. The derivative of y is 1, so that drops away, and we're just left with what's in front of it. Plus, the derivative of y to the third is 3y squared. Okay. Now those are our first partials. Now our second partials. Our first one looks like this. It says we're going to take the partial with respect to x of what we just found here. So we take a look at this. Take the derivative with respect to x. The 4x to the third becomes 12x squared minus, and again, we're treating of y like a constant, so it's like you got negative 14y out in front. And derivative of x is 1, so that drops away. Well, we can also, picking on the same derivative here, we can take the partial of that with respect to y. And if so, the 4x to the third drops away. And over here, the negative 14x is a constant, so it stays out in front. And derivative of y is 1. So we get negative 14x. Okay, let's go over here to the partial with respect to y. Well, we can take that with respect to y. So if I continue here, negative 7x squared, that drops away. There is no y there, is there? And then derivative of 3y squared gives us 6y. We can also take the partial of y with respect to x. So we'll take this with respect to x, and that gives us negative 14x. And 3y squared doesn't have an x in it, so it drops away. Now notice, this right here is the same as that. That's what they're indicating in the note. Observe that second mixed partials are equal. And they are. So we can take a look at our next one. And again, I'm going to use this notation because I like it better. It's kind of self-documents. So e to the y cosine of x. And we want to find our first partials. So I'll take the partial with respect to x. Now the e to the y is just a constant, so that just stays out in front. Derivative of cosine x is negative sine x. So we'll have negative e to the y sine x. Excuse me. Then we'll take the partial of y. Or partial with respect to y, sorry. Cosine x is just a constant, so that stays there. The derivative of e to the y is e to the y. Okay, now going back to this first partial here with respect to x. We can now take that with respect to x, our second partial. Well, again, the negative e to the y is a constant, so it doesn't have any x in it, so it just stays out in front. The derivative of sine is cosine, so this becomes negative e to the y cosine x. And then we'll take the partial of this with respect to y. Sine x is a constant, that stays there. The negative stays there, and derivative of e to the y is e to the y. So this becomes negative e to the y sine x. Now we're going to take the partial of this with respect to x. Again, e to the y is a constant, so it stays there. Derivative of cosine is, actually I did that backwards, didn't I? It was the last time I did with respect to y first. Let me do that. Okay, cosine x is a constant, so that stays there. Derivative of e to the y is e to the y, so this just becomes e to the y cosine x. And then if I take the derivative of this with respect to x, partial that is, The e to the y is a constant, so it stays there, and derivative of cosine is negative sine. So this becomes negative ey sine x. And notice this now matches this, which is what they're indicating to you to notice. Observe the second mixed partials are equal. Do I have room for this? Let's see. Yeah, I probably do. I think the derivative, if I remember right, derivative of this is pretty straightforward. So we got 2x squared plus 5xy plus 2y squared plus 2x minus 2y. Now it says for f of xy, find all values of x and y such that our first partial with respect to x set equal to 0, and our first partial with respect to y set equal to 0. Or is equal to 0 simultaneously. I should have said that. So let's find our derivative first. Okay, the partial with respect to x. Well, the 2x squared becomes 4x. The 5xy, the 5 and the y are constants. The derivative of x is 1, so it drops away. So we got 5y. 4y squared doesn't have an ax, so it drops away completely. And 2x becomes 2. And negative 2y doesn't have any x, so it drops away completely. Then we'll find a partial with respect to y. 2x squared doesn't have a y, so it drops away. 5xy, that gives you 5x. Derivative of 2y squared is 4y. And derivative of negative 2y is negative 2. That's the first part. Find your partials. Then it says set them equal to 0. That's what that instructions is indicating. So we're going to have 4x plus 5y is equal to 4x plus 5y plus 2 is equal to 0. And over here we'll have 5x plus 4y minus 2 is equal to 0. Now this one I can rewrite as 4x plus 5y is equal to negative 2. And this one I can rewrite as 5x plus 4y is equal to positive 2. Now we want to solve these. That's what this simultaneously means. So we've got a system of equations. We've got 4x plus 5y is equal to negative 2. And 5x plus 4y is equal to positive 2. I'm going to use the addition method, the elimination method. So I'm going to multiply my first equation by negative 4 and my second one by 5. Because if I multiply, I'm focusing on the y's here. If I multiply that by negative 4, that gives me negative 20y. If I multiply this by 5, I get a positive 20y. And the y's, when I add them together, will be eliminated. Well, negative 4 times 4x is negative 16x. Negative 4 times 5y is negative 20y. Negative 4 times negative 2 is 8. 5 times 5x is 25x. 5 times 4y is 20y. And 5 times 2 is 10. And now we're going to add those together. Negative 16x plus 25x is 9x. Negative 20y plus 20y cancels. 8 plus 10 is 18. Divide both sides by 9. And we get x is equal to 2. Well, we need to find out what our y is. So I'll plug 2 into one of these equations. Doesn't matter which one. I'll do the first one. 4x plus 5y is equal to negative 2. Put the 2 in for the x. So we've got 4 times 2 plus 5y is equal to negative 2. 8 plus 5y is equal to negative 2. Take the 8 over. Becomes a negative 8. 5y is equal to negative 10. Divide both sides by 5. And we get y is equal to negative 2. So our answer is 2, negative 2. Grab a drink here. Save that page. Okay. Let's take a look at our last problem. got f of xyz kind of a big comma there is equal to e to the x plus z cosine of yz. First off, it wants us to find these three mixed partial derivatives. This is the third partial derivative. So we found the first in this lesson, the first one, then we found the second one. Well, now we're taking one further, so we need the third one. Well, first off, I notice that this beginning one here is x, and this is y. So let's go ahead and find the partial with respect to x first. Cosine yz, there's no x in this, so this is a constant, so it just remains. The derivative of e to a power is e to the power times the derivative of the power with respect to x, since we're taking a partial with respect to x. Well, that'd be 1, and then cosine yz remains. So that gives us e to the x plus z times cosine yz. Well, let's find a partial with respect to y. The e to the x plus z doesn't have a y in it, so that's a constant. That just remains. The derivative of cosine is negative sine. So we're going to have negative sine yz. But it's a chain rule. Derivative of cosine is negative sine, but then we need to multiply times the derivative of what's inside the parentheses with respect to y. Well, the y drops away, and we're just left with z. So we'll have negative z e to the x plus z sine of yz. Okay. Let's come to this first one here. Now we'll take the derivative with respect to y. So it tells you exactly what to do. Just work your way from left to right. So we're going to take this one with respect to y. Well, the e to the x plus z doesn't have a y in it, so that's a constant. That remains. Derivative of cosine is negative sine. So we're going to have e to the x plus z times negative sine yz times, and again, derivative of cosine is negative sine of whatever's inside the parentheses times the derivative of what's inside the parentheses. But we're doing it with respect to y. So the z is just like a constant. The derivative of y is 1, so that drops away, and we just got z. So that gives us negative z e to the x plus z sine of yz. Let me double check that. Looks correct. Well, then we take it with that with respect to y. So take it one further. Well, the all of this out in front just remains out in front because there's no y's in it, so that's all just constant, as weird as it looks. The derivative of sine is cosine times the derivative of what's inside the parentheses with respect to y, because that's what we're doing now. We're taking it with respect to y. Derivative of this with respect to y is again z, so we get negative z squared e to the x plus z cosine of yz. And that's our first answer. Okay. Now, let's look at the other one. It starts as y. What I'm looking at here is, see how we have a y here and we have a y here. Then it's respect to x and respect to y. So we're going to take this and we'll take the partial of that with respect to, was it z? I don't think so. X. Okay, so sine yz is a constant. The negative z is a constant. The only thing that has an x in it is the e to the x plus z. So the partial of this with respect to x is going to be negative z e to the x plus z. Now normally we would multiply times the derivative of what's inside the exponent, but the derivative of x plus z with regards to x, because that's what we're working with, respect to x is 1. So it really doesn't do anything. And then sine yz. So that gives us negative z e to the x plus z sine yz. And we're going to take the derivative now with respect to y. So we're going to just continue on with that one. Again, the very last variable here is what it tells us to take it with respect to with. So, well, this doesn't have any y's in it. This is a constant, so that remains out in front. Derivative of sine is cosine, yz, times the derivative of what's inside the parentheses with respect to y, what we have underlined here, which would give us z, which gives us negative z squared e to the x plus z cosine of yz. Okay. Now this one over here. We're going to start with our first partial with respect to y, which is this right here. So I'm going to write that down again. So negative z e to the x plus z sine of yz. And then we're going to take the partial of that with respect to y. Partial of that with respect to y. Well, the negative z e to the x plus z doesn't have any y, so that's a constant, just remains out in front. Derivative of sine is cosine. So cosine yz with respect to y, so that's times z. Because again, it's like having z as a constant, like you had 2y. The derivative of 2y is 2. So the derivative of zy is z, which gives us negative z squared e to the x plus z cosine yz. Now we want to take the partial of that with respect to x. So we're working our way down. So now it's a partial with respect to our last variable with respect to x. Well, the negative z squared doesn't have an x, so that remains. Derivative of e to the x plus z is e to the x plus z times derivative of the exponent. And we're doing it with respect to x, so the derivative of x plus z is 1 times cosine yz, which gives us negative z squared e to the x plus z cosine yz. What they're indicating here is, remember how we had to mix partials in our second derivative? Well, these mixed partials here give you, in terms of the third partial, give you the same answer. See how all three of these I circled are the same. So let me save that page.
Avast virus database has been updated.
Go away, Avast. And I think that was time for my tablet to blow up. How does it know I'm on my last slide for it to blow up? There we go. And yeah, it is my last slide, so let me go ahead and stop the recorders.